We don't know what happened to the initial carbon dioxide atmosphere of Mars. It is possible that it's gone forever, and that would be bad news for the notion of making Mars habitable. It's also possible that it's hidden in places that we don't see. After all, we've only dug down below the surface a few inches. It would be premature to think that we know everything that's going on about Mars. But it's a mystery, and it's certainly one of the key questions that needs to be answered in terms of, can Mars be restored to habitability?
But first we have to find out what triggered its destruction. The surface of Mars today doesn't seem like the sort of place hospitable to life. It is dry and cold, plunging down as far as -220 degrees Fahrenheit. Its thin atmosphere cannot block ultraviolet radiation from space, which would devastate any known living thing on the surface of the planet. But Mars, which is as old as Earth, might have been more hospitable in the past. The gullies and dry lake beds that mark the planet indicate that water once flowed there. There's also reason to believe, astronomers say, that Mars' early atmosphere was rich enough in heat-trapping carbon dioxide to create a greenhouse effect, warming the surface. In other words, early Mars was a lot like early Earth. If Mars had been warm and wet for millions or even billions of years, life might have had enough time to emerge. When conditions on the surface of Mars turned nasty, life may have become extinct there, but fossils may have been left behind. It's even possible that life could have survived on Mars below the surface, judging from some microbes on Earth that thrive miles underground. Andrew Steele is one of the scientists designing the next generation of equipment to probe for life on Mars. One tool he plans to export to Mars is called a microarray, a glass slide onto which different antibodies are attached. Each antibody recognizes and latches onto a specific molecule, and each dot of a particular antibody has been rigged to glow when it finds its molecular partner. Steele has preliminary evidence that the microarray can recognize fossil hopanes, molecules found in the cell walls of bacteria, in the remains of a 25-million-year-old biofilm. According to Steele, finding signs of life on Mars is by no means the only goal. If you find a habitable environment and don't find it inhabited, then that tells you something. If there is no life, then why is there no life? The answer leads to more questions. The first would be, what makes life-abounding Earth so special? In the end, the effort being poured into detecting primitive life on Mars may prove its greatest worth right here at home. The new study was published in the journal Nature Astronomy on October. A new climate modeling study suggests ancient microbes triggered a climate change on Mars that made the planet less habitable, which may have ultimately led to their extinction. According to the study, simple microbes that feed on hydrogen and excrete methane could have thrived on Mars some 3.7 billion years ago, at about the same time that primitive life was taking hold in Earth's primordial oceans. But while on Earth the emergence of simple life gradually created an environment conducive to more complex life forms, the exact opposite happened on Mars. Sauterre and his team conducted a complex computer modeling study that simulated the interaction of what we know about the ancient atmosphere and lithosphere of Mars with hydrogen-consuming microbes similar to those that existed on ancient Earth. The researchers found that while on Earth the methane produced by those microbes gradually warmed the planet, Mars instead cooled down, driving the microbes into deeper and deeper layers of the planet's crust to survive, slowing down the greenhouse gas effect. At that time, Mars would have been relatively wet and relatively warm, between -10 degrees and 20 degrees Celsius. Sauterre told Space.com it had liquid water in the form of rivers, lakes, and maybe oceans on its surface. But its atmosphere was quite different from that of Earth. It was as dense, but richer in carbon dioxide and hydrogen, both of which acted like potent warming gases. Being farther away from the sun than Earth and therefore naturally cooler, Mars needed those greenhouse gases to maintain a comfortable temperature for life. But as those early microbes started devouring the hydrogen and producing methane, which on Earth acts like a potent greenhouse gas, they actually slowed down this warming greenhouse effect, making ancient Mars gradually so cold it became inhospitable. On ancient Mars, hydrogen was a very potent warming gas because of something we call the collision-induced absorption effect, where molecules of carbon dioxide and hydrogen interact with each other, Sauterre explained. We don't see that on Earth because our planet's atmosphere is not as rich in carbon dioxide as that of Mars used to be. So the microbes essentially replaced a more potent warming gas, hydrogen, with a less potent warming gas, methane, which would have had a net cooling effect. Is life self-destructive on Mars? The findings suggest that life may not have inherent self-sustainable qualities, as some biologists believe had been the case on Earth, until the emergence of humankind. In fact, may be randomly emerging in the universe, only to make itself extinct through its own interaction with the host world. The ingredients of life are everywhere in the universe, Sauterre said. So it's possible that life appears regularly in the universe. But the inability of life to maintain habitable conditions on the surface of the planet makes it go extinct very fast. What do you think? Will humans be able to regenerate life on Mars? Will it benefit human species? Share your views in the comments section and stay curious.